Hi everyone. Okay, for this video today we're going to be looking at finding the gradient of a function using the derivative. Remember that the derivative is a function of the gradient of the curve. So therefore the derivative is an equation that finds the gradient of a curve at any point. Okay? The derivative isn't just some random number, it's not just some random function, it's actually doing something. So let's just look at a really simple example. Let's look at f of x equals x squared. So really straightforward example. So using our derivative rules, we know that f dash x, or the derivative, is equal to 2x. So that means that at any point along this curve, the gradient is equal to 2 times the x value. So if we have a look at, I haven't drawn a very accurate curve, but if when x equals 1 and we draw a tangent line at that point, the gradient is positive and it's relatively steep. So if we have a look at f dash of 1 and we substitute that into our derivative equation, we can see that the gradient is equal to 2. If we have a look at negative 1 and draw a tangent line and have a look at the gradient, we can see that the gradient is negative and it's relatively steep. If we substitute the negative 1 into the derivative function, we find that the gradient of the curve when x equals minus 1 is negative 2. Okay, so that actually gives us the number for the exact gradient of that tangent line. One more example, let's have a look at x equals a half. So if we have a look at a half here, at that point on the curve there, this tangent line is still positive, but it's not quite as steep as it was at x equals 1. So that the tangent is flatter, it's not as steep, so therefore our gradient is going to be smaller. So we have f dash of a half, so we go 2 times a half equals 1. So the gradient is positive and just on a nice 45-degree angle. I hope that helps. There'll be more derivative videos coming soon. Talk later. Thanks, guys.